Okay, we're going to record, we're going to review um, derivatives of logarithms, and let's just review properties of logarithms. So what does this mean? We could say log means find the exponent of 2 to give you 8. The exponent of 2 is 3, so that's what we're doing with logarithms. And then we have ln of x is the same as log base e of x. E is approximately 2.7. Log base 10 of x is the same as log of x, so it's written either way. And then we have these properties. An exponent can be written as a coefficient. If we have the log of a product, it's the sum of the logs. And the log of a quotient is the difference of the logs. This is the change of base formula. So if we have base A, we can change it into base 10. This would be base 10. This is base E. And with calculus, if we have something like this, we're going to rewrite it with base E, natural log, so that we can do the derivative of it. And let's just review simplifying expressions. So if we're going to condense that, we don't want the coefficient there. We need to move it up as an exponent, move that up, and then we can deal with the plus and the minus. So we would have ln x cubed, ln y squared, ln z to the fourth. And now we change these. This would change into a product, and then that would change into a quotient. So we have ln x cubed times x squared divided by x to the fourth. And that's going to help us. These properties, we're going to use these in logarithmic differentiation. All right, let's look at, let's review the derivative of a logarithm. And in the first video, we looked at the graph of natural log. It has a x-intercept of 1, and then at about 2.7, it'll have a y value of 1. So the graph looks like this. And if we just sketched tangent lines and estimated their slope, so we sketch a tangent line and estimate its slope, sketch a tangent line here, sketch a tangent line there, we can see that the slopes are decreasing, and at at 0, the slope is undefined. The function is undefined at 0. And at 1, it looks like the slope is 1. As we move over at 2, maybe we have a slope of 1/2. We do have a slope of 1/2, but we'd have to estimate it if we're doing it this way. So we see the slopes decreasing. Even if we went back up to 1/2, like right here, we see a steep slope. And at 1/2, maybe we have a slope of 2. Then we can see what that graph looks like when we graph all of the slopes. When we're at a fraction, it's high. At 1, we go to 1. At 2, we're at 1/2. And you can see the graph of 1 over x. So we can see that y prime is 1 over x. And this is just evidence. It's not a proof, but it helps you visualize what's happening. So we know now that if we have y equals natural log of x, then y prime is 1 over x. And then we can just go through all the, dealing with all the derivative properties combined with that concept. Oh, we should say derivative rules. Okay, if we have log base 2 of x, let's just do a quick review. We won't do very many of these, but we need to find y prime. So since instead of thinking of a new rule for this, let's just rewrite it as base e. So that's going to be ln x over ln 2. This is equal to that. It's the change of base formula. But then that lets us just write this as a coefficient times the derivative of natural log of x. So we have 1 over x ln 2, and you could just memorize that as a formula, but that's where it comes from. Okay. Find the derivative of that. So now we have an inside function and an outside function. We need the chain rule. So the derivative is the derivative of the outside. That's how we do the derivative of the outside, leaving the inside the same, times the derivative of the inside. So we have 1 over that times the derivative of that. And we'll just leave it like that. Okay, find the derivative of that. Pause the video. We have an outside and an inside. The derivative of natural log, we do 1 over, leaving the inside the same, times the derivative of the inside. So we get cosine over sine, cotangent x. Okay, natural log square root x squared minus 4. Pause the video and try that one. Before we do the derivative, let's write it as write the radical as an exponent. Right now there's an outside, a middle, and an inside. There's 2 chain rules here, but if we rewrite it like this, now we only have 1 chain rule, and we use the property of logarithms. So now the derivative is just going to be 1 over this times the derivative of that. We can simplify. 2's cancel. X over x squared minus 4. Okay, pause the video and try that one. Whether you have the outside and the inside, so we'll do the derivative of the outside means 1 over the inside, leaving the inside the same, times the derivative of the inside. So now we get 1 over x ln x. Okay, here we have a quotient, so use the quotient rule. Pause the video, try that one. So that might be helpful to set up that pattern for the quotient rule. We'll go the denominator times the derivative of the numerator times the derivative of the denominator over the denominator squared. We have x over x and x squared. I'll just leave it like that. Okay, pause the video and try this one. You just have to do the same thing with the power, turn the radical into an exponent. Now, if we did the derivative now, we would have to do chain rule, but also a quotient rule. Due to the properties of logarithms, or due to this property, we can write it like this. Now we don't have to do the quotient rule. Derivative is 1 over x minus 1 times the derivative of x minus 1, which is 1. 1 over x plus 1 times the derivative of x plus 1. And we can just write it like this. Distribute the 1/3. Okay, pause the video, try that one. We write the radical as an exponent. Then we're going to move that. That's a property, power property of logarithms. Now we see a quotient. We can use the quotient property. There's no calculus. No calculus here. I think there could be a confusion when you see that moving out. You think that's the derivative, but as long as there's no prime here, we haven't done any calculus. We're just rewriting it to make the calculus easier. So we'll do the derivative of natural log of 2x. Well, we have 1 over 2x times the derivative of 2x. That's the chain rule. Here we have 1 over x plus 3 times the derivative of x plus 3, 1. And then we can just simplify. We can cancel the 2 and the 2, so it's just 1 over 2x. Here we distribute the 1/2, and it'll be 1 over 2 times x plus 3. And then we can't forget about the product rule. Oh, not the product rule. This is an implicit equation. So we need implicit differentiation because the x and the y are not separated. So find y prime. Before we do that, let's use the property of logarithms to break that up. There's no derivative involved. If we did the derivative, it would be a chain rule and a product rule, but now we don't even have a chain rule here. 1 over x plus 1 over y times y prime. So we're doing derivatives. When we do the derivative of an expression with a y in it, we have to multiply by y prime because we're differentiating with respect to x. Y is a function of x. So I don't know what y is, so I multiply by its derivative, which is the chain rule. This part is the chain rule in implicit differentiation. And now we have to get that isolated. So we're going to go minus 1 over x and minus 5. Let's multiply by y. Then substitute for... No, we'll just leave it like that. Okay, pause the video and try that one. Here, power rule, chain rule. Oops, don't want to do that yet, because then I would have to do a product rule there. Let's just rewrite it. ln x plus ln y equals 2. 2y prime, 1 over x, 1 over y prime, 0. Let's keep the y prime on the left, and we'll move the 1 over x over. 2y prime, 1 over y prime equals negative 1 over x. So we just want to get that to the right, keep the y primes on the left so that we can factor. And we have 2y plus 1 over y. So y prime is, we can write it like this. And probably shouldn't have that y like that. So we can just multiply numerator and denominator by y. So we'll have y in the numerator, and we'll just distribute this to both of those, leave the x out there, and we have y times y, so that's 2y squared, and y times 1 over y is 1. Alright, so that's a review of derivatives of logarithms. And now let's do logarithmic differentiation. So logarithmic differentiation doesn't even have a logarithm in it, but we put a logarithm in it so that we can use the properties of logarithms. So if we were going to find the derivative of this, use logarithmic differentiation. If we weren't using logarithmic differentiation, this would be a chain rule with two product rules inside of it. That's going to be a lot of work. So before we begin, let's write it like this. And then we'll find the natural logarithm of both sides. So we go like this. Which now allows us to move the 1/2 out in front. This is not calculus yet. We're not doing a derivative. And we have another property of logarithms to expand that. So we're going to have 1/2 times ln x minus 1 plus ln x minus 2 plus ln x minus 3. And now we find the derivative. The derivative of this is an implicit equation because we don't have y isolated. So we do the derivative, that's 1 over y times y prime. Now we'll do the derivative here, and that's 1 over x minus 1. The derivative of x is 1, so we don't need to worry about that. We have 1 over x minus 2, 1 over x minus 3. We want y prime isolated, so we'll just multiply both sides by y. And if we don't take the algebra too far, we can just leave it like this. And y, we know, was equal to this, and we just copy this and substitute it for y. So instead of having a y there, we'll put the radical and we'll just stop there. We have the steps down. And I meant we'll stop there on that problem. There was more algebra that could have been done. But this is the last example. So let's differentiate using logarithmic differentiation. Pause the video and try this one. Now we have natural log of y, natural log and that allows us to move the exponent. We can also change the quotient into a difference. Remember that there is no property to expand this. We have to leave it as it is. So we have the derivative of ln y as 1 over y prime. We'll take the derivative of that 1 over x squared minus 1 times the derivative of this is 2x. The derivative of natural log, we have 1 over x squared plus 1 times the derivative of that is 2x. And we want y prime by itself, so we'll multiply by y on both sides. We can do some canceling here. If we distributed the 1/2, it would cancel this 2. It would also cancel that 2. So y prime is x over x squared minus 1. This will be x over x squared plus 1 times y. And we just substitute this for y. All right, and we'll stop there.